Guys, this is going to be your last lecture for Thanksgiving. It's called Ionic Nomenclature. Nomenclature is a fancy word for naming, so we're going to learn about naming ions or ionic bonds. So make sure you have your notebook out and you're ready to take notes. I'm just going to warn you before we start, this is going to be a little bit of a longer lecture probably, but hopefully you're able to watch the whole thing, stay with it, stay focused, because it's going to be really important. And you're going to have to know how to do this, not only for the test, but for the rest of the semester. Alright, so there's some rules that we have to talk about when we're talking about how we can name ionic bonds. So you don't need to write this first part if you don't want to. This is just a review. So if you remember, ionic bonds, they're when we have a transfer of electrons. So I wrote an ionic bond down here. It's NaCl. So we know in NaCl, Na is going to donate an electron to Cl. And so when it does that, Na now has a positive charge, and Cl has a negative charge, and then they are attracted or bonded together because of these charges. And it's a really strong bond. So we have to be able to name now this NaCl. What is its name if I were to ask you it? So we're going to learn that first. So like I said, there's some rules when it comes to ionic bond. So the first thing with ionic bonds is that you're going to put your metal first. And then you're going to put your non-metal second. So if you remember on your periodic table, if you're looking at your periodic table, all ionic bonds, you have a metal on this side that's bonded with a non-metal on this side. So for example, Na is about here on your periodic table, Cl is about here on your periodic table, and they form a bond. So it's with a metal or a non-metal. Sometimes we refer to this as saying that your cation comes first when you're doing a name, and that your anion comes second when you're doing a name. So if you remember, a cation is a positive charge, okay, and your anion is this negative charge. So you put the positive charge first and the negative charge second. So now let's actually write the name. So you're going to be using the names on your periodic table. For the first part, the metal part, it stays exactly the same. So you just find Na on your periodic table and you write the name down. So if you look in group 1A, you see Na is sodium. So sodium is the first part of its name. So this is going to stay the same. For every ionic bond that you do, the first part stays the same. The second part, however, is going to change. So how this is going to change is that you put the ending of your thing, the ending changes to "ide." Alright, so this is what you change the ending to. So for example, if you find chlorine or Cl on your periodic table, its name is chlorine, right? And instead of writing chlorine, you're going to change this ending part to say "ide." So instead of chlorine, you're going to say chloride. So it's sodium chloride. Alright, let's do a little bit of practice next. Okay, so you guys pause the video and try this one. We're going to do Libr. Alright, pause and do it. I'm going to keep going. So remember, it doesn't change. The first part doesn't change. So Li you find on your periodic table and it's lithium. And then Br on your periodic table is on your right side and it's bromine. But remember, we're going to change the ending part. So instead of the "ime", we're changing it to "ide". So bromide. Alright, so you have lithium bromide. That is the name of Libr. On your homework and on the test, I also might ask you to go backwards. So instead of giving you this and asking you for that, I might give you the whole name and you need to then give me the symbol. So I could ask you to go in reverse. So let's practice one of those. So I could say, what is the symbol for magnesium? And let's do sulfide. So give me the symbol for magnesium sulfide. So again, pause the video, figure it out. I'm just going to show you. So it's going to be Mg, because that's magnesium symbol, and then sulfide, S. So MgS. That's how I figured it out. So like I said, this video is going to be a little bit longer because now we need to learn something new about this. For any of these, we have to make sure that we balance charges. So if you notice, Li, or let's go to this top one, the NaCl. So Na, when it creates an ion, it creates a +1 ion, right? We've already learned that. Hopefully you're feeling really comfortable with that. If not, you need to email me. You need to get help because we need to fix that and figure it out. The next one, Cl, it has a charge of -1. So for every one Na, there can be one Cl, right? Because these charges balance, 1 and 1. Down here at this magnesium and sulfide example, Mg has a charge of +2, and S has a charge of -2. So those also balance each other. But what happens, let's say we're trying to figure out the symbol, the MgS, the symbol, except instead of that, we're going to try to do it for potassium nitride. All right, potassium nitride. We're going to try to get the symbol for that. So we know potassium is a K. And we know that nitrogen, if we find it on our periodic table, nitride is nitrogen. That's an N. So it's going to be K and it's going to be N. But if we look at our charges, we'll see they're not balanced. So think in your head, what is my ion charge for K? It's going to be a +1, right? So it's just a +1. What's my ion charge for N? It's going to be a -3. So you notice now these aren't the same numbers anymore. So for your nitrogen, you're going to have -3 and your potassium is going to be +1. So we always need to have more potassium ions than nitrogen ions, right? So there's a simple way that we can learn how to do this. If you'd like to learn a different way, a little bit harder way, that will help you understand it better, we can talk about it in class. But just for this video, how you're going to figure out what you're going to do for your element symbols is you're going to do a thing, it's called cross, drop, and simplify. So you're going to cross these down like this. And so you're going to have a K3 and an N1. You also never have to put that 1 in there. I'm going to erase it. I'm just showing you that for this example. But you don't ever have to put a 1. Remember, it's just like the charges. If it's a 1, we assume it's 1. If it's anything besides a 1, you have to put a number. So a K3, N, and we leave it. And then we have to simplify. So we crossed them, we dropped them, and then we have to simplify. 3 and 1, they're as simple as they get. So that's how you do it. You have to figure out the charges, and then you have to make sure that they'll balance out. So let's do another one. Let's do it with, how about aluminum oxide? I know at this point you might be a little confused. So if you don't feel comfortable stopping the video and trying it yourself, that's okay. But if you feel like you might be able to try something, pause and try it. If not, I'm just going to keep going. So we have aluminum, which is going to be Al. And then we have oxide, which is going to be O. Aluminum's ion is going to be a +3. And oxygen's ion is going to be a -2. So we notice those charges don't balance. So we have to do our crossing and our dropping. And so when we do that, we get an Al2O3. And then we simplify it, and those are as simple as they get. So you see that it's La2O3. All right. Hopefully we're feeling pretty comfortable with that. Let me see if there's any other good practice ones that I can give you. Let's just do one more practice, and then you guys can try on your homework. Let's see. Let's do... Let's do beryllium, and let's do chloride. Okay, beryllium, chloride. So, we know beryllium is Be, and chloride is Cl, or chlorine. Again, pause if you want to try to do by yourself. So, Be has a charge. You go to the top of your periodic table where we wrote the charges, and it's a +2. You go to a chloride or a chlorine, and it's going to have -1. So we cross them and drop them. Whoops, I have the eraser on. We cross and drop them. And so we have a Be, and remember we don't have to put that 1, and then we have a Cl2. So that's how you figure it out. Just as a note on your homework, it might ask you things like, it might say something along the lines of, if you were to have, or it might say like, in this problem, BeCl2, how many chlorines are there? So you know that this 2 tells you there are 2 chlorines. Or maybe it'll ask you about this one, the Al2O3, saying how many aluminums. You'd say 2 aluminums, you'd say 3 oxygens. Or it might say that you have an atom that's made up of 3 potassiums and 1 nitrogen, and you would know that 3 potassiums would be K3, 1 nitrogen would just be N. So I might ask you questions like that, so be prepared for those things. Hopefully this video is clear enough for you. If not, I can try to post some practice problems or things like that, so please email me if you have trouble while you're working on your homework, and I can help you figure them out, okay? Good luck. Let me know if you need